In the ever-evolving landscape of space exploration and technology, individuals behind the scenes often play pivotal roles in ensuring mission success. One such figure is Megan Harvey, who serves as the Utilization Flight Lead and Capsule Communicator for NASA. Her contributions are critical as the agency pushes the boundaries of human presence in space, particularly aboard the International Space Station (ISS). With a career marked by dedication and innovation, Harvey exemplifies the caliber of professionals driving NASA's ambitious objectives. Megan Harvey's role involves overseeing the utilization of the ISS, which includes optimizing the station's resources for scientific experiments and technology demonstrations. The ISS is a unique laboratory that allows us to conduct research in microgravity, which has implications for everything from medicine to materials science, Harvey explained. Her responsibilities also extend to communicating crucial information between the crew aboard the ISS and the ground control team. A role that requires a blend of technical expertise and interpersonal skills. As NASA prepares for the next phases of its exploration agenda, including potential crew cutbacks due to budgetary constraints, the importance of effective mission management becomes increasingly apparent. Reports indicate that prior to recent budget discussions, NASA was already considering adjustments to its crew size on the ISS. This move could significantly impact the number of experiments conducted in space, highlighting the delicate balance between funding and scientific advancement. We need to be strategic about how we allocate our resources to maximize our scientific return, Harvey noted, underscoring the necessity for innovative solutions as the agency navigates fiscal challenges. In parallel, the integration of advanced technologies into space missions is becoming more pronounced. Embry-Riddle Aeronautical University recently announced that its Eagle team is advancing to the finals of NASA's Blue Skies competition with a drone system designed to manage livestock herding. This initiative not only showcases the versatility of drone technology but also reflects the collaborative spirit of innovation that NASA fosters among educational institutions. Our goal is to demonstrate how technology can solve real-world problems both on Earth and beyond, said a spokesperson from the university. Meanwhile, NASA is also contending with external factors such as potential solar storms that could disrupt satellite communications and power grids on Earth. Recent warnings from the agency about a massive solar storm highlight the vulnerabilities of modern infrastructure to space weather. As Harvey and her colleagues manage the complexities of human spaceflight, the implications of solar activity on terrestrial operations cannot be ignored. Preparedness is key. We need to ensure that both our human and robotic missions are resilient to such events, she emphasized. Looking ahead, the intersection of human ingenuity and technological advancements will be crucial as NASA and its partners forge new paths in space exploration. The collaboration between academic institutions and government agencies not only accelerates innovation but also prepares the next generation of aerospace professionals. As the landscape of space exploration continues to evolve, individuals like Megan Harvey will undoubtedly remain at the forefront, guiding humanity's journey beyond our planet while navigating the challenges that lie ahead. The future of space exploration is bright, and with dedicated professionals and cutting-edge technology, the possibilities are limitless. In a landscape where space exploration continues to captivate global interest, NASA's recent announcements highlight the multifaceted roles of its personnel and the ongoing challenges posed by budget constraints. Among the notable figures is Megan Harvey, who serves as the Utilization Flight Lead and Capsule Communicator. Harvey's work is pivotal in facilitating communication between astronauts aboard the International Space Station (ISS) and mission control, ensuring that operations run smoothly and effectively. On May 21, 2025, NASA introduced Harvey in a feature that showcased her critical responsibilities, emphasizing the importance of her role in optimizing the utilization of resources aboard the ISS. Our job is to maximize the scientific output of the station while ensuring the safety and well-being of the crew, Harvey stated, underscoring the delicate balance of operational efficiency and human factors in space missions. Her leadership, especially during challenging missions, has been instrumental in fostering collaboration among astronauts and scientific teams on Earth. However, the backdrop of Harvey's achievements is clouded by significant budgetary pressures that NASA is currently grappling with. Reports indicate that long-standing budget shortfalls could lead to reductions in crew sizes aboard the ISS as well as a decrease in research activities. This situation was exacerbated by recent budget proposals from the Trump administration, which hinted at potential cuts to NASA's funding. According to a statement from a NASA official, these financial constraints pose a serious risk to our continued presence in low Earth orbit and the scientific endeavors that accompany it. As NASA faces these challenges, discussions about crew reductions and mission scaling back are intensifying. Industry experts warn that such cuts could undermine years of research and innovation, particularly as the agency prepares for future missions to the Moon and Mars. The ISS has long been a cornerstone for scientific research and international collaboration, and any reduction in its operational capacity could hinder progress in numerous fields from biology to materials science. Adding to the urgency, upcoming events in Houston will bring together NASA astronauts to discuss their recent experiences aboard the ISS. These discussions are not merely a celebration of achievements but a critical examination of what the future holds for astronauts and the scientific community reliant on the ISS. As astronaut missions increasingly become a blend of scientific inquiry and public engagement, the conversations at these events will likely shape perceptions and expectations about the future of human spaceflight. With the ever-evolving landscape of space exploration, the balance between funding, operational capabilities, and scientific output hangs in the balance. As the world looks toward an ambitious future in space, the decisions made today regarding budgets and program directions will have lasting implications. For NASA, the path forward may require not only innovation in technology and mission planning but also a renewed commitment from policymakers to support the exploration that inspires generations. As Harvey and her colleagues continue their vital work, the hope remains that the spirit of exploration will prevail, ensuring that humanity's reach into the cosmos is not curtailed but expanded. In a remarkable convergence of space exploration and agricultural innovation, NASA is making strides toward establishing sustainable practices for growing crops in space. This initiative comes at a time when the agency faces pressing challenges related to budget shortfalls that could impact its ongoing missions aboard the International Space Station (ISS). As plans for future lunar missions intensify, the need for self-sustaining systems in space is becoming increasingly critical. During a recent event in Houston, NASA astronauts discussed their latest missions aboard the ISS, highlighting the vital research being conducted on long-duration space travel and its implications for future exploration. Understanding how to grow food in space is essential not only for sustaining astronauts on long missions but also for future colonization efforts on the Moon and Mars, said one astronaut, emphasizing the dual purpose of these agricultural experiments. The cultivation of crops in space is not merely an experiment, it is a necessity. NASA's ongoing research into growing crops like lettuce and radishes in microgravity conditions has shown promising results. These studies aim to determine which crops can thrive in space and how to maximize yield while minimizing resource consumption. The agency's efforts are part of a broader strategy to ensure that astronauts can grow their own food during long-duration missions, thus reducing reliance on resupply from Earth. However, these ambitious plans are tempered by financial realities. Recent reports indicate that NASA is grappling with long-standing budget constraints that may force the agency to scale back its ISS crew and research activities. Our budget is being stretched thin, and without adequate funding we may have to make tough decisions about which missions to prioritize, a NASA official explained. This uncertainty raises concerns about the continuity of research that is crucial for long-term space habitation. In addition to agricultural research, NASA is also racing to land astronauts on the Moon, particularly in light of advancements made by international competitors. The Chinese have really caught up, one NASA administrator noted, underscoring the urgency of maintaining leadership in space exploration. The proposed Artemis missions aim to return humans to the lunar surface by the end of this decade, opening the door for further exploration and the establishment of a sustainable presence on the Moon. As NASA navigates these challenges, the implications for the future of space exploration are profound. The integration of agricultural practices into space missions not only enhances the feasibility of long-term human presence in space but also paves the way for potential colonization efforts on other celestial bodies. The agency's success in these endeavors could redefine humanity's relationship with space, transforming it from a distant frontier into a new habitat. Looking ahead, the intersection of agricultural research and space exploration will remain a focal point for NASA. As the agency works to secure funding and develop innovative solutions for growing crops in space, the outcomes of this research could very well dictate the trajectory of future missions, with the stakes higher than ever. The coming years promise to be pivotal for NASA and the broader vision of human expansion into the cosmos. In a significant week for space exploration and technology, various developments have emerged from leading institutions like NASA and Embry-Riddle Aeronautical University. These advancements not only underscore the continuing evolution of space research but also highlight the challenges faced by organizations involved in pushing the boundaries of our understanding of the universe. NASA recently announced a series of initiatives aimed at optimizing the International Space Station ISS operations amidst ongoing budget constraints. According to sources within the agency, long-running budget shortfalls may necessitate reductions in crew sizes and scientific research conducted aboard the ISS. A NASA official stated, "While we remain committed to maximizing the scientific outputs of the ISS, financial realities are forcing us to reassess our operational capabilities." This development comes at a critical time as the ISS has been pivotal in advancing human knowledge of space health and technology since its inception. The implications of such reductions could hinder ongoing projects that rely heavily on the unique microgravity environment provided by the ISS. In another exciting development, teams from Embry-Riddle Aeronautical University have reached the finals of NASA's Blue Skies competition with an innovative drone system designed for herd management. This initiative showcases the intersection of aerospace engineering and agricultural technology with the potential to revolutionize how livestock is managed, particularly in remote or difficult terrains. A representative from Embry-Riddle remarked, "Our drone technology not only enhances the efficiency of herd management but also ensures the welfare of animals by minimizing human intervention." The team's progress in the competition highlights the increasing role of technology in agriculture, reflecting a broader trend of automation and remote management in various sectors. Meanwhile, the agricultural sector is also looking toward space for inspiration as NASA continues its research into growing crops in extraterrestrial environments. This initiative is crucial for future missions to Mars and beyond, as sustainable food sources will be essential for long-duration space travel. NASA's ongoing experiments aim to determine which crops can thrive in controlled environments that mimic Martian conditions. A NASA scientist noted, "Understanding how plants adapt to these extreme conditions is vital for future colonization efforts." The ability to grow food in space could significantly impact not only interplanetary missions but also agricultural practices on Earth, particularly in areas facing climate challenges. However, not all news is positive. The Trump administration's recent decision to close a historic NASA research center in New York has drawn criticism from various stakeholders in the scientific community. The center has been a cornerstone of aerospace research and innovation for decades. Critics argue that this closure could stifle advancements in technology that are crucial for national security and economic growth. An industry analyst commented, "Shutting down such an iconic facility sends a troubling message about the value placed on scientific research and innovation in the United States." As the landscape of space exploration and research continues to evolve, it is clear that the interplay between technological advancement and financial realities will shape the future of these ambitious endeavors. With the world watching closely, stakeholders in the field must navigate these challenges while striving to maintain progress in space exploration. The coming months will likely reveal how institutions like NASA and universities can adapt to these pressures while continuing to foster innovation and exploration beyond our planet. NASA's Mars rover Curiosity, equipped with cutting-edge technology and an insatiable curiosity, has recently presented an intriguing set of findings from the red planet. As the rover traverses the Martian landscape, it continues to capture the imagination of scientists and space enthusiasts alike, especially with its latest observations of the planet's atmosphere and geological features. In a striking photograph released on May 21, 2025, Curiosity captured a moody Martian sky that sparked interest due to its stark contrast to the typical celestial backdrop of stars. Instead of the expected twinkling lights, the rover's cameras revealed a unique atmospheric phenomenon, highlighting the complexities of Martian weather. What we saw wasn't a star but rather an unusual atmospheric event, said a NASA spokesperson, emphasizing the rover's role in enhancing our understanding of Mars' climate. In addition to its atmospheric observations, Curiosity has recently rolled into an area known as the Crocodile region, a site believed to harbor some of the oldest rocks on Mars. This geological exploration is part of a broader mission to uncover the planet's history and its potential for past life. Curiosity's chief scientist noted the rocks in this region could provide vital clues about the environmental conditions that existed billions of years ago. As Curiosity continues its journey, it is leaving behind the ridge area where it previously conducted thorough examinations of rock formations. The mission team has meticulously planned this transition, setting the rover on a path that will allow it to analyze these ancient geological formations. We are excited about the opportunities that lie ahead, as these rocks may tell us more about the planet's evolution and its capacity to support life, the chief scientist added. Curiosity's findings come on the heels of another NASA rover, Perseverance, which is also actively exploring Mars. Perseverance is particularly focused on the search for biosignatures, further complementing the work of Curiosity. Together, these rovers are part of a larger strategy to gather comprehensive data that could inform future missions, including potential human exploration. The interplay between these two missions enhances our understanding of Mars, providing a more holistic view of its environment and geological history. As scientists analyze the data collected by Curiosity and Perseverance, they anticipate significant revelations that could reshape our understanding of the red planet. As NASA continues to invest in Martian exploration, the implications of these findings extend beyond the scientific community. The excitement generated by discoveries on Mars enhances public interest in space exploration and inspires future generations of scientists and engineers. With advancements in technology and ongoing missions, the coming years promise to unveil even more of Mars' secrets, potentially leading to groundbreaking discoveries that could alter our perception of life beyond Earth. In an era marked by renewed interest in lunar exploration, NASA is taking significant steps to enhance its capabilities for future moon landings. On May 20, 2025, the agency announced its latest initiative aimed at simulating manual piloting for lunar landings, a critical skill that astronauts will need for upcoming missions. This innovative approach seeks to equip astronauts with essential piloting skills that could prove vital in emergency situations, ensuring both safety and mission success as humanity prepares to return to the moon. The initiative comes in response to a rapidly evolving space landscape where international competitors are making strides in lunar exploration. As NASA Administrator Bill Nelson remarked, the Chinese have really caught up, highlighting the urgency for the U.S. to not only maintain its leadership in space but to also push the boundaries of human exploration. With countries like China advancing their lunar programs, NASA recognizes the necessity of refining its training methodologies to ensure that American astronauts are fully prepared for the challenges of manual piloting in the unpredictable lunar environment. NASA's focus on manual piloting comes at a time when automation is often favored in space travel. However, the complexities inherent in lunar landings, including the moon's uneven terrain and potential landing hazards, make a human touch essential. According to NASA's Artemis program team, while our spacecraft are designed to assist The ability of an astronaut to take control in critical moments could be the difference between a successful landing and a mission failure. The training will utilize sophisticated simulators that replicate the lunar environment and the intricacies of piloting the spacecraft during landing. This hands-on experience is crucial as it allows astronauts to familiarize themselves with the spacecraft's controls and develop the reflexes needed to respond to unforeseen circumstances. By integrating manual piloting into their training, NASA aims to foster a robust skill set among its astronauts, preparing them for scenarios where quick decision-making and manual control could be life-saving. As this initiative unfolds, it is also reflective of broader trends in space exploration, where nations are accelerating their efforts to establish a human presence beyond Earth. The imminent passage of a house-sized asteroid between Earth and the Moon on May 21, 2025. serves as a reminder of the dynamic and potentially hazardous environment of space. NASA's proactive approach not only seeks to enhance astronaut training but also underscores the importance of vigilance and preparation in the face of such cosmic challenges. Looking ahead, the implications of NASA's renewed focus on manual piloting extend beyond immediate mission readiness. As the agency gears up for the Artemis missions, which aim to land the first woman and the next man on the Moon, the development of comprehensive training programs will be pivotal. The lessons learned from these exercises will not only inform lunar missions but could also lay the groundwork for future endeavors, including potential manned missions to Mars. In conclusion, NASA's commitment to refining astronaut training through manual piloting simulations marks a significant step in its preparations for upcoming lunar missions. As the agency navigates a competitive global landscape in space exploration, the emphasis on human skills in piloting underscores a balanced approach between technology and human expertise. As we stand on the brink of a new era of exploration, the ability to adapt and innovate will be crucial in shaping the future of space travel.